So, hi everyone, we are going to look at integration by substitution. As we look about that, integration between cos and sine can get confusing. So that's why I came up with a mnemonic that will help you at least get the differentiation and the integration of the two easy. That is, don't count stars, instead start climbing. So we have a positive here and a negative here. The derivative, D stands for derivative, I stands for integration. The derivative of cos is negative sine because of the sign here, and the derivative of sine is positive cos. The integral of sine is negative cos because of the sign here, and the integral of cos is positive sine because of the sign here. I hope that is clear. So we can start the first example. What is the integral of x squared root x cubic plus 5 dx? You take part of the function to be represented by u. As we go on, you will get to understand how to choose which part of the function to be represented by u. In this case, we are taking our u to be this, x cubic plus 5. The next step will be to find the derivative of u with respect to x. Du dx will be 3x squared. The derivative of x cubic is 3x squared, and the derivative of a constant is 0. The next step is to make dx the subject. To make dx the subject, we take dx the other side and we bring 3x squared the other side, so that our dx will be du over 3x squared. After finding the derivatives, now you can substitute everything in our initial integral. What was our initial integral? X squared root. Now this will be replaced by u. And our dx now becomes this, du 3x squared. The x squared can cancel out with the x squared. Now you can see why we chose this part of the function to be represented by u, so that when we differentiate the function, this part of the function, we can get 3x squared and this x squared, which will cancel out with that. As you do more examples, you will be comfortable which part of the function to choose. Anyway, so there is a 1 here, du over 3. Over 3 is the same as a third. We take a third outside the integral. Anytime you are finding the integral of a function, the constants can move outside the integral, and we remain with root u du. We can clear out these. That will be a third. The integral of root u can also be written as half du. So that will be a third. The integral of u raised to a half, that will be u half plus 1 over half plus 1 plus c. Remember, when we are integrating, we will add the power by 1 and divide the function by the result. plus c. And this will be a third u raised to 3 over 2 over 3 over 2 plus c. Now, what is a third divided by 3 over 2? A third divided by 3 over 2, that will be 2 over 9 u raised to 3 over 2 plus c. But what was our u? Our u was x, so our final answer will be 2 over 9 u, which was x cubic plus 5 raised to this 3 over 2 plus c. There is no space there, plus c. So this is our final answer. Let's look at another example. What is the integral of 2x? Let's write this x properly. 2x root 1 plus x squared dx. So we let our u to be this 1 plus x squared. The next step is to find the derivative of u with respect to x. That will be the derivative of 1 is 0, the derivative of any constant is 0, the derivative of x squared is 2x. The next step is to make dx the subject. We take dx the other side and bring 2x the other side. So that will be du over 2x. Now after finding the derivative and making dx the subject, you substitute everything back in our original integral. That was 2x root. This now is our u dx, which is this du over 2x. Now 2x can cancel out with 2x and we remain with the integral of root u du. That is the integral of root u can be also be written as a half du. The integral of u raised to half, that is u a half plus 1 over a half plus 1 plus c. That will be u 3 over 2 over 3 over 2 plus c. We can erase this out. So that will be, this is u raised to 3 over 2 divided by 3 over 2. So when you take 3 over 2, u divided by 3 over 2, that is the same as 2 over 3 times u 3 over 2 plus c. But what was our u? Our u was, so our final answer will be 3 over 2 u, which was 1 plus x squared 3 over 2 plus c. So this is our final answer. We can look at another example. So let's erase everything out. Another example, what is the integral of sec squared 3x minus 1 dx? So we let our u to be this 3x minus 1. We find the derivative of u with respect to x. This will be 3. The next step is to make dx the subject. That will be take dx the other way and bring 3 the other way. That will be du over 3. Now substitute everything in our original integral, which is sec squared u. Our dx is now this du over 3. Du over 3, that's like a third du. A third is, this is a constant, it goes outside. Remember, when you have constants in the integral, you bring them outside the sign. And we remain with sec squared u du. So what is the integral of sec u, with sec u squared? The integral of sec u squared, that will be tan u plus c. I'm wondering how I got tan u. The integral of sec squared is in the standard integral tables, so you don't need to be worried about this. If you check the standard integral tables, they always provide the integral of trigonometric functions, and from the table the integral of sec squared u is tan u. We can erase this one out. But what was our u? So our final answer will be a third tan u, which is 3x minus 1 plus c. So this is our final answer. We can look at another example. What is the integral of x plus 1 sine x squared plus 2x plus 2 dx? So let our u to be this x squared plus 2x plus 2 du dx. Finding the derivative, that will be 2x plus 2. The derivative of 2x is 2. The derivative of 2, a constant, is 0. Next, make dx the subject. So when we make dx the subject, take dx the other side and divide 2x plus 2 by du. That will be du over 2x plus 2. Now let us substitute everything in our initial integral. That will be x plus 1 sine. Now this becomes our u. Our dx is this, which is du over 2x plus 2. X plus 1 sine u du over, now note here 2x plus 2 can be factored further, and we will have 2x plus 1, because 2 times x is 2x and 2 times 1 is 2. X plus 1 can cancel out with x plus 1, and we remain with the integral of sine u du over 2. Over 2 is the same as a half. Now, as we said, the integrals will always be pushed outside of the integral sign. So that is a half the integral of sine u du. What is the integral of sine u? From our mnemonic earlier, don't count stars, instead start climbing. A positive here, a negative here. So the integral of sine u is negative cosine. Our answer becomes half negative cos u plus c. But what was our u? So that is half negative cos that's negative cos x squared plus 2x plus 2 plus c. So this becomes our final answer. We can push the negative. So we can write it properly. Sorry. Let's write this answer properly. Erase everything. Erase everything. That will be a half negative cos x squared plus 2x plus 2 plus c. This is our final answer. We can do 2 or more examples. Sorry. What is the integral of sine x e cos x dx? We let our u to be. From this integral, you will automatically know that we want our u to be cos x, so that when we find the derivative, which becomes to have a negative sine x, which will cancel out with sine x. Anyway, let us go on. This from our earlier mnemonic, we can just don't count stars, instead start climbing. Positive, negative. So the derivative of cos is negative sine. Okay, negative sine x. We make dx the subject. Make dx the subject. Take dx the other way. Bring sine x the other way. We have du over negative sine x. We can substitute everything in our initial integral. Sine x e raised to u dx, which is now this du negative sine x. Sine x can cancel out with sine x, and the negative sign, we push it outside because this is like -1. We push it outside the integral. E u du. So what is the integral of exponential u? The integral of exponential u is exponential u. So our final answer is u plus c. But what was our u? Our u was cos x. So our final answer is e cos x plus c. This is our final answer. Before we go to another example, I would like to share about this, the integral of exponential. The integral of exponential kx. whereby k is any constant, this will always be the answer. 1 over k e kx. For example, what is the integral of e? 2x, where x is any function. That will be half e 2x. In the example we have just done, we had e u. We were differentiating with respect to u. But there's a 1 here. Whenever you have a number, whenever you have a function, a variable, there is a 1 behind it, which is not that very significant. The integral of this with respect to u will be 1 over 1 e 1 over u, which is the same as e to u. So remember this formula, it is important. Let's do another example. What is the integral of e exponential 3x over 1 plus e 3x dx? We let our u to be 1 plus e 3x du dx. We find the derivative of this is 0. The derivative of a constant is 0. The derivative of exponential 3x is 3 e 3x. We make dx the subject, take dx the other way, and bring this the other side. That will be du over 3e 3x. Substitute everything in our original function, 3x over. This now becomes our u. Our dx is this, du 3 e 3x. Exponential 3x can cancel out with exponential 3x. Du over 3 is the same as, this is like a third du. Push a third outside the integral, because whenever you have constants inside the integral, you push them outside the sign. So this becomes the integral of 1 over u du. We can erase this one out. Erase this one out. The integral of 1 over u is ln u plus c. When the integral of 1 over u, the integral of 1 over u is always ln u. But what was our u? Sorry for this, don't mind that. Our final answer becomes a third ln u plus c. This is our final answer. We can look at one example whereby we are given limits. Now, given the integral of 2x plus minus 3 over root x squared minus 3x plus 1, given the limits 3 to 5. Now our final answer will not have c, because when you integrate integrate a function that does not have limits, you will always include the addition of c. But when you integrate a function with limits, you will leave out the addition of c. Anyway, let's go on. That will be let our u to be. This will be our u. X squared 3x plus 1. The derivative will be 2x minus 3. Take dx the other way and bring this the other way to make dx the subject. That will be du over 2x minus 3. Substitute everything. Now, before we substitute everything in our original function, we have to make 3 and 5 to be compatible with the u world, because this 3 and 5 is for the x. But now when we are substituting everything back to u, when we used u, we also have to make 3 and 5 compatible. Now, from this expression, u is equals to x squared minus 3x plus 1. What will be our u when our x is 3? That will be 3 squared minus 3 plus 1. Our u will be, that is 9 minus 9 plus 1. Our u will be 1. And what will be our u when our x is 5? That will be 5 squared minus 5 plus 1. We are substituting everything here. Our u will be 25 minus 15 plus 1. Our u will be 11. Now we can substitute everything in our original integral. That will be the integral of 1 to 11 now, not 3 to 5, but 1 to 11, when everything now becomes compatible with u. 2x minus 3 over root. The function that was here now is replaced by u, and our dx is now du 2x minus 3. 2x minus 3 can cancel out with this, and we remain with the integral of 1 to 11, 1 over root u du. That is the integral of 1 to 11, 1 over u. Root u can also be written as a half du. That is the integral of 1 to 11. Yeah, we are correct. U raised to 1 over 2, which is a half. Now, remember from linear algebra, whenever you have something like this, 1 over, let's say, 2 raised to 2, this is the same as 2 raised to negative 2. This, we take this, the upper side, but we include negative in the power. Say you are given something like maybe 1 divided by 3 raised to 5. This is the same as saying 3 raised to negative 5. Now, given here, this one here, 1 over u raised to negative 2, this is the same as saying u raised to negative half. Whenever you have a function or a number raised to a power, when you make it the numerator, the power gets a negative behind it, like this. We can go on So from here now we can write 1 to 11 u negative half du. So this is integrating u raised to negative half, that is u negative half plus 1 over negative half plus 1. Now our limits, we will not now include the positive c, the addition of c, because we have the limits. The limits was from 1 to 11. This is u raised to half over half 1 to 11. U raised to half, negative half plus 1 is a half. So u raised to half divided by 1 over 2. Divided by 1 over 2 is the same as saying 2 over 1 times u raised to half from 1 to 11. Divided by half, when you take half, that will be 2 multiplied by this. Anyway, so this is 2 u 11 raised to half minus 1 raised to half. We are including now from 1 to 11. That will be 2. Since we have common powers here, we can say root 11, 11 raised to half now becomes root 11 minus root 1. This is 2 root 11. What is the square root of 1 is 1. So this is our final answer.